Hello all. In the last class we completed stability of carbocations by using resonance effect. Now let us continue applications of resonance. Okay, next application is stability of carbon ions. Okay, what are carbon ions? Carbon ions are electron rich species. Minus M groups increase the stability of carbon ions and plus M groups decrease the stability of carbon ions. Okay, I given some minus M groups and some plus M groups. Okay, let us start stability of benzyl carbon ions because benzyl carbon ion stability is very important. Okay, let us start. First example, benzyl carbon ion benzyl carbon ion okay, NO2 minus M group, OH plus M group, and that is neutral. Okay, see what we have to do. First write all the effects. Minus M, yes, give tick mark. Every minus M group also has minus I effect. Minus M, minus I, tick marks. OH is plus M group, tick mark. Every plus M group also having minus I effect. Minus I is common, right? For minus M group and for plus M group, minus I is common. And this is neutral. Okay, right. Which is more stable? A is more stable. Why? Because minus M is present. Minus M groups increase the stability of carbon ions, right? A is more stable. A after C is more stable. Why? Because C is neutral. A greater than C greater than B. B is least stable. Why B is least stable? Because in B plus M group is present. Plus M groups decrease the stability of carbon ions. Okay, right. Next example. Example 2. I am taking same group in different positions, NO2 group. Okay. Now first of all, write all the effects. NO2 is a minus M group. Minus M and minus I. Minus M and minus I. Okay. Here NO2 is having minus I effect? No. Why? Because it is present in meta position. When a group is present in meta position, its effect do not works. Okay, its plus M effect or minus M effect do not works. So I am cutting minus M. Okay, right. There is no minus M because NO2 is in meta position. But I is present. Inductive effect is present in all the positions, ortho, meta, para positions. Okay. Now here minus M, yes, minus M is present. Why? Because NO2 is in the ortho. In ortho and para, resonance will work. Okay, works. Minus I. Right, which is more stable carbon ion? See, we can eliminate option B. Why? Because minus M is not at all present. Carbon ions are stabilized by minus M groups. Okay, but here minus M is not present. So we can eliminate the second one. Second one is least stable. Right? Okay. Second one is least stable. No problem is with A and C only. In A and C, which is more stable? Observe in A, minus M is present. Here also minus M is present. Then minus M is cancelled. Na? Here minus M is present. Here also minus M is present. Okay, right. Here minus I is present. Here also minus I is present. But what is the difference in minus I here and minus I here? Here minus I, where it is? Here minus I is away from the carbon ion. See the distance. Minus I here carbon ion is present. Here minus I, here carbon ion is present. Here minus I is closer. We know inductive effect is a distance based effect. Inductive effect is a distance based effect. Here minus I group is closer to carbon ion. See, and we know minus I groups stabilize the carbon ion. NO2 is having its minus I power, and NO2 is closer to carbon ion. So this is stable. Stable. Are you getting the concept? Minus M here and minus M here can be cancelled. Effect is same. Okay. For resonance or mesomeric concept, effect of resonance is same. Means effect of donation or withdrawing is same in ortho position and in para position. Okay. For example, here NO2 is taking some electrons from the carbon ion. Here same amount of electrons will go towards NO2. For example, if NO2 withdraw some 20 electrons from this carbon ion, this NO2 also withdraw some 20 electrons. Mesomeric effect or resonance effect is same whether the group is in para position or whether the group is in ortho position. But inductive effect is not same. Inductive effect is a distance based effect. Here NO2 is having some minus I power. Its another role is it acts as a minus I, right? Here its minus I effect is more, withdrawing effect is more, stabilization is more. For carbon ions, minus I group should be very closer, we know in inductor. Okay, so what is the stability? C greater than A greater than B. B is least stable. Why B is least stable? Because in B, minus M is not at all present. Okay, right. Example 3. Let us discuss one small general example. What is that general example? Let us consider a person who is lifting some weights on his head. For example, he is lifting some 100 kg. Okay, one person is lifting some weights. Okay, if you place more weights on this person, what happens? Person will get a instability. Okay, if you remove the weights from the head, then he will get the stability. Clear? Remember that part. Let us compare this person as carbon ion. Carbon ion. Carbon is having negative charge. Carbon is having negative charge. Means carbon is lifting some weight. Carbon is lifting some weight. If you increase more weight, means if you increase more charge over the carbon, then carbon will get a instability. It will become unstable. Becomes unstable, right? Okay. Why I explained this small story, you will get. Look at this. This is one carbon ion. Allyl carbon ion. Allyl carbon ion. Example 3, option A. This is propyl carbon ion. Propyl carbon ion. Okay. Now consider this carbon as a person who is lifting some weights. Okay. Here also consider this carbon as a person who is lifting some weights. If you wanted to do help for this person, what you have to do? You have to remove the weights from that person's head, right? Clear? Look at this. In which carbon ion weight over carbon will be removed? Okay? Who will help carbon ion? Who will remove the weights, means charge over the carbon ion? Okay? Let us see. In the first option, due to resonance, this negative charge will comes towards this side, towards unsaturated center, means towards a double bond. Okay, because of resonance, carbon is losing its negative charge, losing its weight, will become stable. Because negative charge is removing or not? This example. If person loses weight, then he will get stability. Why carbon is losing weight? Because of resonance. Resonance condition, we know, double bond which is connected adjacent to an atom with a negative charge, then resonance is taking place. Resonance takes place. Clear? But what about this? Ethyl group is a plus I group. Ethyl group is a plus I, electron donating group. Electron donating group. What it will do? it will donate electrons and increases electron density over the carbon head, and the carbon becomes unstable. Clear? Got it? So this is stable. A is greater than B. So you have to check for resonance. Okay? Just a second. Right. One special example I'll explain. Example 4. Actually, this is not related to resonance. Just a general question. Example 4. This is not related to resonance concept. A general question. This is a general question. Triple bonded carbon with negative charge is more stable than double bonded carbon, and double bonded carbon is more stable than single bonded carbon. Okay, so stability order C greater than B greater than C. This is general example. Okay, right. Next question. A and B, which is more stable? This is also important example. Once again, let us consider carbon ion as the person who is lifting the weights. Okay, here carbon is lifting some weight. Okay, if you wanted to do the help for carbon ion, you have to remove the weight from the carbon ion, right? See this benzene. What is the role of benzene? Due to resonance. Why resonance is present? See, double bond present adjacent to carbon with negative charge. Resonance is present. So this negative charge will shift into resonance, and carbon will get stability. Carbon is losing the weight now, so it will get stability. Okay, means this benzene ring is helping the carbon ion. Benzene ring is taking the weight. Hey, give the weight, I'll lift for some time. Benzene is saying like that. Then carbon will feel stability, because benzene is helping the carbon ion. See, the weight is moving towards benzene. Now benzene is lifting the weight. Clear? Okay. In this case, two persons are helping. This is one person and this is one person. Two persons are helping. So this negative charge may go this side or may go this side. Two persons are there to help. So here stability is more. Stability is more. Clear? So what is the stability order? B greater than A. Got it? Right. Next application, stability of, acidic nature of phenol. Acidic nature of phenol. For acidic nature, concept is same. Whatever it may be the functional group, whether it is alcohol or carboxylic acid or phenol, whatever it may be the functional group, concept is same. Minus I, minus M should be present. Okay, remember that point. So here also I am writing same statement. Minus M groups increase acidic nature of phenols. Minus M groups increase acidic nature of phenols. Plus some groups decrease acidic nature of phenols. Okay, statements are same. Statements do not change. Okay, right. Let us see the reaction which is responsible for the acidic nature of phenol. We can take bonds also or circle also. Both are same only. This reaction is responsible for the acidic nature of phenol. This is the reaction. Okay, this is conjugate base, phenoxide ion. What is conjugate base? The negative ion formed after removal of H plus from the acid is called conjugate base, phenoxide ion. Right. What is the statement? Minus M groups increase acidic nature of phenols. Why? These minus M groups stabilize the conjugate base phenoxide ion. That's why they increase the acidic nature. Remember, theoretical question. Minus M groups increase the stability of conjugate base phenoxide ion and thus increase the acidic nature. Plus M groups destabilize the conjugate base and they decrease the acidic nature of phenoxide ion, acidic nature of phenol or acids. Okay, right. And write Ka pKa relation. Here also Ka is directly proportional to acidic nature, pKa is inversely proportional to acidic nature. Okay, Ka is directly proportional to acidic nature. pK is inversely proportional to acidic nature. Let us start the examples. First example, most probable area in the GOC, acidic nature of phenols, benzoic acidic nature, basicity of amines. Okay, I am taking plain phenol. Here phenol with NO2. Phenol with some plus H, hyperconjugation, donation, or you can consider it as a plus M. Actually we have to consider it as a plus H, but we didn't start hyperconjugation. Let us consider it as a plus M, no problem. Okay, what is NO2? It is a minus M. This is neutral. We know what is the relation or statement. Minus M groups increase acidic nature. This is minus M, right? So B is more acidic. So B is more acidic. B after A after C. Why C is least? Because here donating group is present. Donating groups decrease acidic nature. Okay. So which is more acidic? B. What is name of B? Para-nitrophenol. In para position, nitro group is there. Names also important. Okay. Para-nitrophenol. Para-nitrophenol. Note down, this is para-methylphenol. This is para-methylphenol. Okay, right. Which is having more Ka value? Second one, more Ka. Which is having more pKa value? More pKa means less acidic. Which is less acidic? This is less acidic. So more pKa. More Ka, more pKa. Okay. Now let us start some exceptional cases. Right. Example 2. NO2 in ortho position, orthonitrophenol. Most important example is very important example. Orthonitrophenol, para-nitrophenol, metanitrophenol. Orthonitrophenol, para-nitrophenol and metanitrophenol, which is more acidic. Which is more acidic. See, at the beginning I given one reaction which is responsible for acidic nature, right? Which reaction is responsible for acidic nature? Once look at this. See the reaction. Phenol is losing H plus. right? You know arginous acid, what is arginous acid? The substance which gives H plus ions, which release H plus ions is called as acid, right? If any substance releases H plus or loses H plus easily, it is said to be good acid. Clear? So the compound should lose H plus ions easily, not with difficulty. Clear? Right, remember that point. Right. Out of these three, which compound loses H plus easily and which acts as good acid? That is the question, right? Okay. First of all, write general effects in which minus M is present, in which minus I is present. Okay, right. NO2 is in ortho position, so NO2 having its minus M power and minus I power. Here NO2 is in para position, so NO2 is having minus M and minus I. Here NO2 is in meta position. In meta position, minus M do not works. Okay, that's why cut minus M. Cut minus M. Minus M do not works in the meta position. But minus I is present. Yes, minus I is present. Clear? Just a second. Just I am checking whether recording is going or not. Okay, right. We can eliminate option C. Why? Because there is no minus M. For acidic nature, once look at this. For acidic nature, minus M group should present. Minus M groups increase acidic nature. If minus M group is present, then compound will be more acidic. Phenol will be more acidic. But here minus M is absent. Where it is? Sorry. Here minus M is absent. Why minus M is absent? Because NO2 is in meta position. So eliminate this. This is least acidic. Least acidic. Now problem is with these two only. Right. In these two, which is more acidic? Very important example. See. In orthonitrophenol. In orthonitrophenol. I am writing this structure, rewriting like this. Just I am expanding the structure. NO2 group. In orthonitrophenol, what happens? Hydrogen bonding takes place. In chemical bonding, you know, consequences of hydrogen bonding. Under consequences of hydrogen bonding, you studied. Okay? Right. Hydrogen bonding, the weak electrostatic force of attraction between more electronegative atom and hydrogen is called as hydrogen bonding. Hydrogen bonding. See, because of hydrogen bonding, this hydrogen is tightly held by NO2 group. NO2 group. For example, look at this. This marker is H plus. This marker is H plus. And this hand is oxygen atom. This hand is oxygen. Now oxygen is holding this H plus. Now see, oxygen is releasing H plus. Oxygen is releasing H plus. If one compound releases H plus easily, that is said to be good acid, right? Now in this case, what is happening? See, oxygen is holding H plus, and this, consider this as nitro group. Nitro group is holding H plus tightly. How it is possible to release H plus in this case? In this case, you cannot release H plus, right? Because NO2 is holding that H tightly. Here, NO2 group through oxygen atom holding this hydrogen tightly. So release is difficult. Release is difficult. If release of H plus is easy, then only that compound acts as good acid. Here release of H plus only difficult, right? Because of hydrogen bonding. Which type of hydrogen bonding? Intramolecular. Intra means within the same molecule. We have two types, inter and intra. Because of intramolecular hydrogen bonding, release of H plus is difficult. So orthonitrophenol acidic nature is less compared to paranitrophenol. Very important question. Clear? So A, orthonitrophenol is less acidic. Now A is less than B. Okay, B is more acidic. Okay. Overall order. B greater than A greater than C. C is least. Why C is least? Minus M is not at all present in C. Okay. Right. Very important example. When you get orthonitrophenol, paranitrophenol, metanitrophenol, which is more acidic? Paranitrophenol is more acidic. Why paranitrophenol is more acidic? In paranitrophenol, there is no hydrogen bonding. This hydrogen is free hydrogen, so release is easy. Release is easy. But in this case, what happens? This hydrogen is tightly held by NO2 group. So release of hydrogen is difficult. Release of hydrogen is difficult. Remember that point. Clear? Right. Let us see another example. Compound A general name is very important. What is general name? Let us give IUPAC name, then general name. What is this IUPAC name? Its IUPAC name 246. 246 trinitrophenol. Names also important. 2, 4, 6 trinitrophenol. 246 trinitrophenol. Commonly it is called as, so common name is very very important, picric acid. Commonly it is called as picric acid. Okay. And this is 1, 2, 3, 4, 5, 6, 2, 4 dinitrophenol and paranitrophenol. Which is more acidic? Guess which is having more Ka value. More acidic means more Ka value. Which is having more Ka value? In which more minus sum groups are present. If more is the number of minus sum groups, then more will be the acidic nature. So order is A greater than B, B greater than C. Okay, that hydrogen bonding example, and this example is very important. Okay, right. Example 4. I wanted to explain one exceptional case. Actually, in the college we skip this example, but I'll try to inject this example. Okay, if possible, learn, otherwise take light, especially NEET students. Well, for JEE students, this is important. For NEET students, just optional only. Means when paper will become very difficulty, then you will get these type of questions. Clear? But I will explain. Try to remember, try to understand, and try to remember. Okay. Parafluorophenol. Parachlorophenol, parabromophenol, and para-iodophenol. Arrange the following in the increasing or decreasing order of their acidic nature, or which of the following is a strong acid, or which of the following has highest Ka value, highest pKa value. Like that we will get the questions. Clear? If I give the questions and if I ask you to say the answer, what you will say? 100% you will say, sir, parafluorophenol is more acidic. Why? Because it is having a strong minus I power. Clear? Your answer is that only, na? But second option is correct. Why second one is more acidic? Even though chlorine is having less minus I power compared to fluorine, but why second one is more acidic? Let us see. That's why I said this is exceptional case and very important for JEE mains, especially for NEET students also important, but rarely you will get these type of questions, right? Okay, let us do one thing. Write conjugate basis for all. Write a conjugate base. How to write conjugate base? Remove H and write the conjugate base. O negative fluorine. O negative chlorine. Here also O negative and the bromine. O negative and the iodine. Okay, right, here also same story. One person is lifting some weights on his head, okay, like this. Some 100 kg weights he is lifting. That person is nothing but oxygen. Oxygen is lifting some weights. Negative charge means electron density. Let us consider electron density as the weight. Oxygen is carrying some weight. Oxygen is searching for help or waiting for help. Okay. This fluorine ready to help oxygen by removing the weights. Chlorine also ready to help because all these are electronegative atoms now. They are ready to take the electrons. Okay, they are ready to help oxygen. Now oxygen is carrying more weights on his head. Okay, which group, which atom will help oxygen and stabilize the oxygen? Let us see. Okay, fluorine is ready to help oxygen. Okay, in order to do the help for oxygen, what fluorine has to do? Fluorine has to take the weight from the oxygen head, and fluorine has to carry that weight. Okay, clear? Right. Okay, fluorine aim is to help the oxygen only. Fluorine ready to take the charge or weight, okay, towards itself. But after taking the charge, where fluorine will accommodate that charge? That is the question. For example, one person is lifting some 100 kg weight. Okay, what I did, I took that weight. If I keep that weight on the bench, okay, then that is comfortable for me and that person also. I should have some place, okay, to put that weights, right? Clear? I am taking the weights. I have to place that weights on the bench or on the floor. Clear? Then that is good for both of us. But fluorine is not having empty space to accommodate that electrons. Fluorine is ready to take the electrons only, no problem. But where it will keep the weights? For example, I am ready to help one person. I am taking the weights from that person's head. But I do not have any space. In this room, benches are not there. Okay, table is not there. I should not, let us consider, I should not keep that weight on the ground. That is the rule. Then what I have to do? I have to carry. Okay, I have to carry in my hands. But how much time I will carry? After some time, I also will feel some difficulty now. So that's why I will give return. Clear? Then again person will get instability. Fluorine, why fluorine is not having vacant rooms to accommodate that charge? See, fluorine belongs to, just a second, second period elements. This is first, second, third and fourth. What are the orbitals? 1s, 2s, 2p, 3s, 3p, 3d. 4s, 4p, 4d and 4f. Okay. In third period onwards, d orbitals are starting. Clear? In second period, d orbitals are not present. What are second period elements? Carbon, nitrogen, oxygen, fluorine. What are third period elements? Silicon, phosphorus, sulfur and chlorine. Okay, in second period elements, vacant d orbitals are not present. These are d orbitals, 5 suborbitals. In second period, vacant d orbitals are not present. Remember that point. Okay, right. Fluorine belongs to which period? Second period. So fluorine is not having vacant d orbitals. Clear? So fluorine is ready to take the electrons or weight from the oxygen, but there is no place for the accommodation of that electrons. That's why fluorine won't take that electrons. But chlorine belongs to which group? Which period? Sorry, third period. In third period, vacant d orbitals are present now. So I am writing vacant d orbitals here. These are vacant d orbitals. So excuse me. So chlorine will take the electrons. See, due to resonance, this negative charge enter into the ring and enter into the vacant d orbitals. Chlorine is taking the electrons, means chlorine is removing the weights from the oxygen head and putting that weights in the vacant rooms. Clear? That is the reason. So chlorine means chlorine substituted phenol is more stick because of d orbital resonance. Remember the reason also, d orbital resonance. Because of d orbital resonance, para-chlorophenol is moristic. Okay. In bromine and iodine also vacant d orbitals are present, but we do not take into consideration because of a large energy gap between bromine and carbon. Here carbon is there now, bromine is there now, large gap is there. That's why phenomena do not take place like this. Here one phenomenon is taking place now, shifting of electrons into d, because chlorine and carbon energy levels are very close. That's why shifting is easy. Bromine energy level is more, carbon energy level is less. Energy level means energy. Shifting is difficult. Iodine, large energy gap, so shifting is difficult. This is shifting from chlorine to vacant d, means from carbon to vacant d. Shifting is easy here, but here carbon to vacant d shifting is difficult. Why this is not possible? Here also not possible. Why? Because of large energy gap. Instead of that, you remember para-chlorophenol is more acidic. Very simple thing over. Okay, but I explained the reasons also. Clear? So what is overall order? B greater than A greater than C greater than D. Clear? In remaining we consider minus I only. Fluorine is having more minus I na, so that's why fluorine will come after chlorine. Clear? Iodine is least acidic because its minus I power is less. Okay, for chlorine only we consider vacant d orbital concept. For remaining we consider minus I effect, which is having more minus I effect. Fluorine is having more minus I effect. That's why next fluorine will come. Clear? Important example. This is also right. Next. Another example. Keep it as a neutral. Which is more acidic? See, I given chlorine and NO2. NO2 is a strong minus M group. Chlorine is having minus I. Okay. But resonance is taken into consideration. NO2, generally NO2 is a strong minus I, and in minus I order also NO2 is in the strong position, right? Clear? Compared to chlorine. So A greater than B greater than C. This is very simple, easy example based on the strength. Okay, right. Next, acidic nature of carboxylic acids. Acidic nature of carboxylic acids, especially benzoic acid. Benzoic acid acidic nature, right? What is benzoic acid structure? This is benzoic acid. Benzoic acid acts as acid by losing H plus. Here also same concept, minus M groups increase. Minus M groups increase acidic nature. Plus M groups decrease acidic nature. Ka is directly proportional to acidic nature, pKa is inversely proportional to acidic nature. That statements are same, no doubt. Okay, let us start the examples. Before going to start the examples, another important concept or definition I will give you, that is Ortho effect. Ortho effect. Ortho effect. Very important. Ortho effect. What is ortho effect? See, first of all, definition. Ortho substituted benzoic acid is stronger stronger than remaining isomers, stronger than remaining isomers. This is called as ortho effect. Ortho substituted benzoic acid is stronger than remaining isomers. Remaining isomers means meta and para. Okay, once look at this, I am giving a generalized example. COOH. Here I am taking some plus M or minus M in ortho position. In ortho position, whatever it may be the group, whether it is plus M or minus M group. Okay, ortho substituted benzoic acid is always greater than, this is greater than symbol, greater than remaining isomers. Remaining means para plus M minus M. Meta. Later we will discuss between these two, which is more, we will discuss later. Okay, plus M or minus M. Okay. Ortho substituted benzoic acid is stronger acid than meta or I wrote both are meta only. Now just a second. Plus M minus M. Para, meta. Okay. Para isomer, meta isomer. These two are less acidic than ortho. Very, very important. Very, very important. So when you get the question on benzoic acid acidic nature, first check whether any group is present in ortho position or not. If any group is present in ortho position, then that benzoic acid is stronger acid. Okay, let us start the examples. First example based on the ortho effect only. Example 1. Names are very, very important here. Names are most important. Okay, I'm giving the name. Generally, this is called as orthomethyl benzoic acid. Orthomethyl benzoic acid is easy only, na? Everyone can say. But another common name is there, orthotaulic acid. Orthotaulic acid. M stands for metataulic acid. Metataulic acid and parataulic acid. Names are very, very important. Okay. First of all, which is more acidic? What is ortho effect? What is ortho effect? Ortho substituted benzoic acid is stronger acid than remaining isomers. Okay. Which is ortho substituted benzoic acid? This is ortho substituted benzoic acid, right? It will be stronger acid, more acidic than remaining. Clear? So we can eliminate first one. First one will be more acidic, because that is ortho substituted benzoic acid, right? Between these two, which is more acidic? Okay, I said to consider CH3 as a plus M group, donating group. Okay, actually its effect is hyperconjugation. Positive hyperconjugation is donation only. Okay, nothing will happen. Consider it as a plus M through hyperconjugation. Right, here plus M, here also plus M. But in which plus M will works? This is para position. Plus M will works in para position. Plus M will not work. Plus M or minus M will not works in meta position. Meta. Remember, in meta position, plus M do not works, minus M do not works. Clear? Right. First one is more acidic because of ortho effect. Don't check any effect, means plus I, minus M, minus I. Don't check. Just if you observe any substituent in the ortho position, that will be more acidic, no doubt. Clear? Now coming to these two. Okay. Which is more acidic? For acidic nature, what I said, plus M should not present, plus I should not present. For acidic nature, minus I should be present, minus M should be present. Plus M should not present. If plus M should not present, then that compound is more acidic. plus m should not present or minus m should be present. That is a criteria for acidic nature. Clear? Minus I minus m should be present, plus m plus I should not be present. Okay, where plus m is not present in meta position, see there is no plus m, so this is more acidic. Donating group should not present according to our concept. Here donating group is present, decreases the acidic nature. Clear? So overall order A greater than B, B greater than C, very important. Orthotolic acid is more acidic than metatolic acid. Metatolic acid is more acidic than paratolic acid. Why paratolic acid is less acidic? Because here plus m is working, plus m is present. Clear? Right. Let us see another example. And another model questions are common. Which of the following is having more Ka value? This is having more Ka value because more acidic, more Ka. That questions are common only, right? Let us see another example. Orthonitrobenzoic acid, metanitrobenzoic acid, and paranitrobenzoic acid. Guess which is more acidic, which is having more Ka value. Apply ortho effect, which is ortho substituted benzoic acid. First one is ortho substituted benzoic acid, na? So what is the definition of ortho effect? Ortho substituted benzoic acid is more acidic than remaining isomers. So this is more acidic. Clear? Orthonitrobenzoic acid is more acidic. Okay. So A is more acidic. Now problem is with these two only. First write the effects. NO2 is a which group? Minus M group, right? NO2 is a minus M. But here minus M is present in meta position, so minus M do not works. That's why I cut into mark. Minus I is present, but minus M do not present. Here, yes, here minus M is present. Minus M is present. Minus I is common. Right. First one is more acidic because of ortho effect. Cleared. Between these two, which is more acidic? For acidic nature, which group should be present? Minus M group should be present. For acidic nature, minus M or minus I. Clear? But we give priority for minus M only. Okay. When minus I, minus M both are present, both are operated, give priority for minus M only. Clear? Okay. Here minus M is present. Minus M groups increase acidic nature, right? Minus M groups increase acidic nature. Plus M groups decrease acidic nature. Minus M should be present. Plus M should not be present. Clear? Here minus M is present, so it is more acidic. Here minus M is not present. Why minus M is not present? Because NO2 is in meta position. In meta position, minus M do not works. In meta position, minus M do not works. A is more acidic because of ortho effect, and C is more acidic next because minus M is present, and B is least acidic because of absence of minus M effect. Clear? So what is overall order? A greater than, C greater than B. B is least. Why B is least? Because there is no minus M. Why there is no minus M? NO2 is in meta position. Clear? Right. Overall acidic order. Overall acidic nature. Very important. Overall acidic nature. Overall acidic nature. You have to by heart this overall acidic nature. Formic acid is more acidic than benzoic acid. Benzoic acid is more acidic than aliphatic carboxylic acid. Aliphatic carboxylic acid is more acidic than phenol. Phenol is more acidic than water. Water is more acidic than alcohol. Remember this overall acidity order. Very important. Formic acid is more acidic than benzoic acid. Benzoic acid is more acidic than aliphatic carboxylic acid. Aliphatic carboxylic acids are more acidic than phenol. Phenol is more acidic than water. Water is more acidic than alcohol. Let us see one question on this overall acidic nature. Which of the following has highest Ka value? Which of the following has highest Ka value? Sometimes you will get the names also, that's why I am giving the name. What is its name? Benzoic acid. C2H5OH, which is having more Ka value. Which is more acidic? Which is more acidic? See the overall order. Formic acid means this only, na? So answer is formic acid. Formic acid after benzoic acid. This is more acidic. This after, this is more acidic. After that, this one is more acidic. Okay, right. Next one, basic nature of amines. Basic nature of amines. Plus M groups increase basic nature, minus M groups decrease basic nature. For basic nature, concept is reverse. For basic nature, plus M group should be present. For acidic nature, minus M should be present. For basic nature, plus M groups should be present. Okay. Aniline basic nature. Very simple example. What I said, plus M groups increase basic nature. Which is plus M group? This is plus M. And what is which group? Minus M group. This is neutral. So what is the overall basic nature? A greater than, C greater than, B. B is least basic. Why? Because NO2. In inductive effect I explained what is basic nature. Once revise that videos. Okay? Watch that videos. And you know one point. What is Ka? Acid dissociation constant, Ka. Similarly, we have base dissociation constant Kb. Kb is directly proportional to basic nature. Okay, and pKb is inversely proportional to basic nature, like Ka pKa. Here also we have Kb pKb, basic nature. Which is having highest Kb value here? This is having more Kb value because basic nature is more, Kb is more. Which is less acidic. This is less acidic. Less acidic means more pKb value, right? This is one general question. General question. Let us see one a different example. This is pyridine. Pyridine, sorry, pyrrole. This is pyridine. Pyridine and pyrrole. Once again, I will revise the definition of basic nature. What is a base? Lewis base. Electron pair donor is called as Lewis base. Electron pair donor is Lewis base. The one which gives electron pairs means the nitrogen. If gives electron pair easily, then the compound is said to be good base. Nitrogen is carrying lone pair. Here also nitrogen is carrying lone pair. Right. For example, let us consider proton. Proton is waiting for the electrons. If this nitrogen gives electrons easily to this H+, this compound is said to be good base. If this nitrogen gives H+ easily, then this compound is said to be good base. Okay. This example depends on the aromaticity, concept of aromaticity. See in pyridine, sorry, in pyrrole, remember, this lone pair enter into the resonance to satisfy aromaticity. Okay. Donation is difficult. Why? Because this is busy in resonance to satisfy the aromaticity. I will tell you aromaticity concept. Okay. Just you remember in between pyrrole and pyridine, which is more basic. In pyridine, already aromaticity is present within the ring. Aromatic character is present within the ring. So this lone pair do not enter into the ring. Already 6 pi electrons are present. You know 4n plus 2 pi electron rule, Haeckel rule, aromatic character. So this is free pair, free lone pair. So donation is easy. If donation is easy, basic nature is easy. So this is more basic. Pyridine is more basic. Clear? Very important example. So between pyrrole and pyridine, which is more basic? Pyridine is more basic. Why? Because lone pair is very easy to donate. Clear? We'll continue in the next class. Okay. Thank you.